Okay, so the first thing we need to do is we're going to just add two 8-bit numbers together. So the way I do it is I start on this side and add the two digits together. So 0 plus 0 is 0, 0 plus 0 is 0, 0 plus 0 is 0. Okay, so now I've got to the first bit where I've got to start thinking. I've got 1 plus 0, well that's going to be 1. I've then got 1 plus 0, which is 1. And I've got 0 plus 1, which is 1. Okay, so now the first time I've got to think about it starting to carry. 1 plus 1 is 2. The way I represent 2 is I put a 1 in the next column, and I put a 0 in the column that I'm working in. Okay, so the next one is 1 plus 1 plus 1, so that is 3. So I put a 1 in the next column and a 1 in the column I'm working on. But because I only want 8 bits, I have to throw away that last bit of information. Okay, so this question is about binary shifts. And what it's asking me to do is identify the result of applying a logical shift of 2 to the binary number 0111010. Okay, so what I'm going to do is I'm going to move every value 2 to the left. Okay, so the 0 will move 2 spaces and become where the 1 was before. The 1 will move 2 spaces to here, and I'll just do that all the way along. So what I end up with is this value. Because I am doing a logical shift in 8 bits, I don't continue on, so I don't get the last bit of the conversion. Okay, so this bit here on the end, the 011 that it starts off with, that will be lost. Okay, so that's an overflow. Okay, so this is asking me to add a positive number and a negative number using 2's complement. So what we need to do is we need to fill in the headings of the table to start off with, and we need to work out what it is it's asking us to do. So let's start off by putting the headings in. So I've got minus 128, 64, 32, 16 as usual for the binary. So to represent 7, because 7 is positive, I don't put a 1 in the minus 128, and I just have the 7 as usual. Because 6 is negative, I have to work out what 6 is, starting at minus 128 and then adding these values on. So I end up with this value here. And then all I do is I add the two numbers together. So 1 plus 0, is 1. 1 plus 1 is 0, carry a 1. 1 plus 0 plus the carried 1 is 0, carry the 1. So I'm going to keep ending up carrying the 1 all the way along until I get to the end, where the end value falls off, and I end up with a 0 in this last position, which is exactly what I'm after, because I want a positive number, because I need the number 1 for that answer. Okay, so the next like-for-like question is asking me to compare the features of sign magnitude with 2's complement to the method of representing negative numbers in binary. Okay, so what we need to be looking for is we need to look for any of the following answers. Okay, so I need to be looking at the 2's complement will always work. Sign magnitude doesn't work in some cases. Okay, the sign magnitude will not always work. There's only one way to represent 0 in 2's complement. There are 2 ways to represent 0 in sign magnitude. So any one of those 4 things will get you the mark. So a quick question about hexadecimal conversion. It's asking me to convert this hexadecimal number that is used to represent a colour into binary. So what I'm going to do is I'm going to have 4 blocks of bits for each one of these letters and numbers. Okay, so starting with the F, I can work out what F is. Well, F is the equivalent of 15, so that would be the 111, 1 at the front of this number. 2 is represented as this block. 3 is represented as this block. 4, this number here is that one. This is A, which is equivalent to 10. This is B, which is equivalent to 11. So as you can see, each one of the hexadecimal digits is represented as 4 binary digits. Okay, so this is a pretty standard question. It's asking me why programmers might prefer to use hexadecimal to binary notation. The two answers that are acceptable is it's shorthand, easier for humans to read, which means it will give you less likely potential mixes up the ones and zeros. What you can't talk about is storage. If you talk about storage, you lose all the marks completely because storage is always binary. All the computer is doing is giving you in hexadecimal, so it's easy for you to read. It is still using binary. Okay, so this question is asking me to work out what W is. Well, if the denary version of Z is 122, I have to figure out how many letters I go back to figure out W. So Z, X, Y, Z. I go back 4 positions, so that gives me an answer of 119. Nice and easy question. Okay, so this question is asking to come up with an expression. Expression just means an equation. So if we look at the question, we've got 24 bits, color, so it's using true color. It's got a display resolution of 600 by 720 pixels, and it wants it in kilobytes. If it's a big bit, it's bytes. If it's a little bit, it's bits. Okay, so let's quickly do the calculation. So the way we do this is first we find out how many pixels there are. So we do 600 times 720. We take that number and we multiply it by the bit depth, which is the number of bits per pixel, and that was 24. So I've now got 600 times 720 times 24. I divide it by 8 to get that into bytes, because that was in bits. And then I divide that whole number by 1024 to turn bytes into kilobytes. So what I end up with is this equation here. The way the marking works is you get 1 mark for doing the first bit, calculating the pixel count, times by the bit depth. So that gives you how many bits you've got. This is the mark you get for converting to bytes, and you get the final mark for converting to kilobytes. Okay, so next like-for-like question. Explain the effect of increasing the sample frequency for a sound conversion. Okay, so this one's 3 marks. You've got to come up with 3 points. So the first point is higher sample frequencies generate more sample data. That increases the memory storage requirements, but it gives you a more accurate digital representation of the original signal. Okay, don't forget you can't say higher quality, lower quality, because it depends on the original signal that you were looking at to describe quality. So quality is not a value we use, it's not a word we try to use in sound conversion.